Okay, so we'll study today graph in kinematics. Okay, graphs in kinematics. Okay, so here we study graph x versus t graph, velocity versus time graph, acceleration versus time graph. Okay, first we start with x versus t graph. So first case, if velocity is constant, if velocity is constant, then graph will look like a straight line graph. Okay, if velocity is constant, then graph will look like a straight line graph. This will represent x axis, this is time axis. Okay, and slope of this graph theta means tan theta will give you velocity. Okay, and slope will be constant. Second graph, when acceleration is constant, if acceleration is constant, then the velocity time graph will look like a straight line. Okay, this will be the velocity, this is time axis. It will look like a straight line, and slope will give tan theta will be acceleration. Okay, in this graph, area under the curve will give you the total displacement. Okay, so this area will give you total, red area will give you your displacement. Right? So this theta means tan theta will give acceleration, area will give you displacement in case of velocity time graphs. Okay, okay. Third case, if acceleration equal to constant, then your position time graph will look like, it will be a parabola. Okay, if a is greater than 0, it will look like that, and if it is less than 0, it will be opposite curve. Okay, fourth case, acceleration time graph. If acceleration time graph is given, okay, then a slope will give you a rate of change of acceleration, This axis is acceleration, this axis is time. This slope will give you rate of change of acceleration. Acceleration, okay. And area under the curve will give you, this curve will give you velocity, okay. So in case of acceleration time graph, area under the curve will give you velocity and slope will give you rate of change of acceleration. Next part is in graph how we calculate average and how we calculate instantaneous. How we calculate average and how we calculate instantaneous, okay. If graph is given, suppose this is your graph, okay. Suppose this is a graph of x and t. I'll give you one example, just you can do it by yourself, okay. And we have a graph like this, okay. So at any instant, suppose we want to find out at this instant the slope of a graph. The slope of a graph will give you so here tan theta will be your velocity and it will be instantaneous velocity, okay. And other velocity, how we find out average velocity, okay. So for average velocity we just need to connect first point to last point and this will give you the average velocity. If it is phi, then your tan phi will give you V average or average velocity, okay. So tan pi will give you average velocity. This is how you interpret the graphs in kinematics, okay.